Welcome to how to construct a confidence interval for a proportion. In this video, we're going to do a quick run through for exactly how to do a confidence interval for a proportion. If you're looking for way more details in terms of what all of the stuff I'm talking about in this video represents, please look at the following video above and it will lead you to a much more detailed explanation. All right, so first off, what are you being asked to do here? Like when you create a confidence interval, what is it you're doing? You're using a sample proportion, that's a p hat, a proportion from a sample, and you're using that to build a confidence interval, to build an interval for what the true population proportion P could be. In most cases, it's hard to ever really know the population proportion of anything because it's, populations are really big. Typically, we all have a sample, and with that sample proportion, we could build an interval to try to estimate what that true population proportion could be. So what do you need to build one of these confidence intervals? Really just three things. You need your sample proportion. You have to have the proportion from your sample that you got. Now that does need to be a decimal. Maybe it's like 0.12 or maybe it was 12 out of 100. If it was a fraction, make it a decimal, but we do like to have that as a decimal. Now proportions do represent percentages, but we don't actually use the percentage. Like we wouldn't say 12%, we would use the proportion value of 0.12. The next thing we're going to need is our sample size n. That's going to be given in the problem. And we need a level of confidence. Now, this is a little bit tough. So again, please look at other videos I have for much more detail on this. But your level of confidence will be given to you. Typically, 95% is very common. 90% is another common one. 99% is also common. But something weird like a 92% could also come up as well, or even 96%. But the problem does have to give you that level of confidence because you will need to know it. All right, here is like the generic formula. Like this is just straight cut to the chase. This is the generic formula for how to actually build your interval. You start with your p hat, that's your sample proportion, and then you add and you subtract what's called the margin of error. This entire back part here is your margin of error. Margin of error. Now, the margin of error is created by doing a couple different things. First, we need a z star multiplied by a standard error of that sampling distribution. So the formula for that standard error is the square root of your sample proportion p hat times the opposite of your sample proportion 1 minus p hat, all divided by the square root of n inside the square root. And then z star, this is linked to your level of confidence, right? That's linked to your level of confidence. How confident do you want to be? And again, if you're looking for more detail on that, please pay attention to other videos of mine that go into a lot more detail. So all we're going to do is we're going to take our sample proportion, we're going to add and subtract this margin of error, which formula is all right there for that, and then you're going to get an interval for where you are pretty confident that the true population proportion can be. Now, there are 4 steps to actually finding a confidence interval. So if you're going to be asked on the AP exam, hey, how do I actually, or let's go ahead and let's actually build the interval. The actually building of the interval is step 3. That's where you actually use the formula I just showed you and do the work to find the interval. But there are 3 other steps that are just as important. Step 1 is actually identifying what is it that you're trying to find in context. So you're identifying the population parameter that you're trying to find. And you're telling me that I'm going to do this, or you're going to do this, with a 1 sample z interval for a proportion. That is the official name of a confidence interval for a sample, for a population proportion. It's called a 1 sample z interval. See, the AP does require that you say that. The second step is to check the conditions that are necessary, that are required for building a sampling distribution. And we want to make sure we do this in full sentences, but very briefly, your sample has to be random to avoid bias. That must be confirmed. Your sample size must be under 10% of the population that it was taken from to assume independence. And your sample must be big enough, which means you have 10 or more successes and 10 or more failures in your sample. And if any of those conditions are violated, then your confidence interval is not going to necessarily do what you want it to do, and that's estimate the truth. Step 3 is actually doing the work. As I mentioned already, that's the fun step. That's the pretty easy step. And then the 4th step is interpreting your interval. This typically starts off with, I'm 98% confident that the true proportion of Cars that are blue is between the interval of 18 and 33%, whatever you end up getting. But you want to make sure you fill in those blanks with a little bit more of the details. And your level of confidence that you're going to use in this statement is given to you in the problem. I just used 98 as an example. All right, so let's just dive into an example so you can see how I do all 4 of these steps in a hurry. Marine biologists have been noticing that more and more aquatic sea fans are becoming infected with a bacterial fungus that is causing the sea fans to die off in extreme numbers. To estimate the proportion of infected sea fans, researchers get a sample of 55 sea fans. There's my sample size. That's one value I'm going to need to know. And they find out that 55 of the 55, 12 are infected. That's going to be my p hat. 12 out of the 55 are infected. And if you need a calculator to figure that out, just, don't be ashamed. 12 divided by 55, because we do want to use the decimal there, is 0.218. All right, so create a 95%. There's the last thing I needed, the level of confidence, a 95% confidence interval to estimate the population proportion of infected sea fans. So in a nutshell, my sample showed that 21.8% of the sea fans in my sample were infected. That doesn't mean that that's what's true for all sea fans, but I'm going to build an interval to hopefully find what's true. All right, step 1, not fancy here, but it is pretty simple. You're identifying what you're trying to find and how you're going to find it. So I will estimate the population proportion of infected sea fans in the Atlantic Ocean with a 1 sample z interval for a proportion. So tell me what it is you're trying to find and use specifics, proportion of infected sea fans in the Atlantic Ocean, and you're going to do that with a 1 sample z interval. Step 2 is checking those conditions. Kind of annoying, I know, but we got to do it here. The sample size of 55 is random to avoid bias. 55 sea fans is assumed to be less than 10% of all sea fans in the Atlantic Ocean to assume independence. And the sampling distribution will be normal since my sample did have 12 infected sea fans, and that would mean 43 non-infected. Both of those numbers need to be larger than 10 or larger to use the model that I want to use here. All right, here's step 3, actually doing my work. So I'm going to start off with my sample proportion, 0.2182. I kept an extra decimal there. Typically, I'm okay with 3 decimal places, but I kept an extra one for fun. I added, I subtracted. I'm literally going to go up and down. That's what actually builds the interval by my margin of error. Remember, this entire back part is your margin of error all put together. So first, let's talk about the standard error. The standard error is the back part. Again, pretty easy formula. I'm just taking the square root of my p hat. That's the 0.2182 again. The opposite would just be 1 minus that p hat. That's where I got the 0.7818 from, all divided by your sample size of 55. Now, where does this 1.96 come from? That is my z star that represents the middle 95% of samples. So if I'm imagining that sampling distribution showing me all possible samples, mine is of course in there somewhere. I mean, all samples are in there somewhere. If I'm hoping that my sample is in that middle 95%, that's where I'm getting confident. 95% of all possible samples will fall very near the mean that is in the middle, the mean of all the p-hats in the center there. So the z star is simply the z-score that represents that middle 95%. Now, how do I get that? Well, a couple different ways. If you have one of these new TI-84 calculators where you can get second vars and go to invert norm on your calculator, and you can actually select 0.95, that's that confidence level, and then select center because that 95% is the 95% in the middle, in the center. And then you get that z star of the negative and positive, that's the plus and the minus, that's where that plus and minus comes from, for the 1.96. Now, if you're new or you're old, or I don't know how new your calculator is, but if your calculator does not have that option to select center, if you don't even have the option to select your tail there, that means you're automatically set to left. So this is where you do have to use your brain a little bit. If I have 95% in the center, that means 5% is left out, 2.5 on the top, 2.5 on the bottom, which is to the left. So I'm going to type in 0.025, that's the 2.5% to the left, which again puts 95% in the middle. And this will get you that 1.96 as well. But again, positive and negative because I got to go up and I got to go down. All right, that's it. Hopefully that all makes sense. Again, got other videos if you want to go through a lot more detail there. All right, type all this into your calculator to get your margin of error all together, 0.1092. We're going to add that, we're going to subtract that, and we're going to create an interval. Our interval here was 0.109. That's what happened when I subtracted it. 2.3274. That's what happened when I added it. Pretty simple stuff there. All right, and finally, the last step is interpreting your interval in context. So I'm 95% confident. Don't forget that part. That part is extremely important because there's no guarantee of this. It's just about a level of confidence. I'm 95% confident that the true proportion of infected sea fans in the Atlantic Ocean is somewhere between 10.9% and 32.74%. My sample showed, like I said, about 22%, but obviously it could be more, could be less. And this is exactly what my interval is doing. It's trying to estimate with a level of confidence where that true proportion of infected sea fans can be. That simple, that easy. Again, if you're looking for more, please look at the following video. It could definitely help you explain a little bit more of the detail here. But in a nutshell, that's how easy it is to find a confidence interval for a sample proportion.